Aaron, this is a podcast about physics to God, not biology to God. Maybe we should explain why we're doing an episode about biology.
Good point, Ellie. The reason we're doing this is because the design argument from biology, which tries to infer God from the complexity of life, has a much longer history than the fine-tuning argument in physics. It goes back hundreds, even thousands of years. However, since the modern theory of evolution seemed to show that the mystery presented by the complexity and diversity of life was not truly evidence for a designer, some people think that any design argument, even from physics, must be wrong. We have to address that issue. How do we know that fine-tuning in physics is truly evidence for an intelligent cause? What differentiates the fine-tuning argument in physics from the design argument in biology?
That makes sense, Aaron. But you know that intelligent design in biology is a real hot-button topic. Are we sure we want to get involved in it? Maybe sticking to physics is a better approach.
That's also true, Ellie. But we're not going to be picking any sides, or even get too deep into the nitty-gritty in the debate in biology. We're only going to tell the story of the design argument in biology for the purpose of showing why the scientific solutions that ostensibly show that an intelligent designer isn't needed in biology are inappropriate for fine-tuning in physics. My name is Rabbi Aaron Zimmer.
And my name is Rabbi Dr. Eli Feder. Welcome to Physics to God. Welcome. This is Physics to God, a guided journey through modern physics to discover God. My name is Eli Feder, and I'm an Orthodox rabbi and a mathematician.
And my name is Aaron Zimmer. I'm also an Orthodox rabbi with a deep interest in physics and philosophy. On this podcast, we'll discuss some of the most fascinating developments in physics and make a convincing argument that they point directly to the existence of God.
We'll get to the fun in just a minute, but remember to subscribe to Physics to God so that you don't miss an episode. Write a review or share it with any of your friends who are interested in science and God. If you have any comments or questions, check us out on Facebook or email us at physicstogod@gmail.com. Also, check out our website, physicstogod.com. Aaron, let's give a short summary of our basic argument up until this point. We began with what Richard Feynman called one of the greatest mysteries of physics. The mystery of the constants challenged scientists to explain their strange values. After many years of unsuccessfully trying to solve this mystery, scientists eventually discovered a great clue, that the constants exhibit a high degree of fine-tuning. From among the vast range of theoretically allowed values, their specific numbers were shown to be necessary for bringing about a complex and diverse universe, which is much greater than the sum of its simple parts.
This shows that the constants have a purpose and explains why they have their specific values, the values needed to cause the complex universe to result. From this, we inferred that the cause which fine-tuned the constants for the purpose of bringing about our amazing universe is intelligent. This is because the term intelligence refers to the ability to select one possibility from among many for the purpose of achieving an intended goal.
Let's now give an overview of what we're going to do today. First, we'll present the design argument in biology. Then we'll discuss the theory of evolution and how it tries to explain the apparent design of life without an intelligent cause. We'll explain why that solution doesn't work in physics, and also show how, even in the framework of biology, it merely pushes the design question back to the origin of life, the design of the first DNA molecule. We'll then talk about the scientific answer to the origin of life problem, the multiplanet solution. We'll show how this type of explanation also isn't justified in physics.
Lastly, we'll go even further and show that fine-tuning in physics can shed new light on design and biology. All this will clarify the major advantages of the fine-tuning argument in physics over the design argument in biology.
The design argument is often associated with William Paley, who in 1802 argued that just as the discovery of a watch points to a watchmaker who designed it, so too the design manifest in nature points to a designer. Actually, this argument was well formulated by the 11th century Spanish rabbi Bachya ibn Pekuda in his book Duties of the Heart as follows. There are some people who claim that the world came into being by chance, without a creator who created it, and without a maker who formed it. It is amazing to me how a rational, healthy human being could entertain such a notion. If such a person heard someone else saying the same thing about a water wheel, which turns to irrigate part of a field or a garden, saying that it came to be without a craftsman who designed it and toiled to assemble it and place each part for a useful purpose, the hearer would be greatly amazed about him, consider him a complete fool, and be swift to call him a liar and reject his words. And since he would reject such a notion for a mere simple, insignificant water wheel, which requires but little ingenuity and which improves but a small portion of the earth, how could he permit himself to entertain such a notion for the entire universe, which encompasses the earth and everything in it, and which exhibits a wisdom that no rational human intellect is capable of fathoming, and which is prepared for the benefit of the whole earth and everything on it? How could one claim that it came to be without purposeful intent and thought of a capable, wise being?
Historically, the design argument was the strongest in biology because living creatures seem to exhibit the greatest degree of complexity in design. However, if you noticed in the quote above, Rabbi Bachya ibn Pekuda didn't exclusively refer to design in living systems, but to design of the universe as a whole. By the end of this episode, you'll know why.
Even though it seemed that the design argument in biology was based upon evidence that the highly complex design found in living organisms implies a designer, Charles Darwin's theory of evolution in 1859 seemed to undermine this evidence. It attempted to explain the great complexity and diversity of life on Earth without the need for an intelligent cause. Darwin showed that complex forms of life can slowly evolve from life forms which are much less complex and much less diverse. The basic phenomenon which enables this process to occur is heredity, the observed fact that parent organisms generally have offspring that closely resemble their parents.
Sometimes, however, offspring will have a random change or a mutation, which makes them slightly different from their parents. While most of these random mutations will be harmful for the offspring, or at best harmless, some will happen to help them survive and reproduce in their environment better than those offspring without the change.
Let's simplify this with a concrete example to help make the idea clearer. Let's imagine there was an insect which has some sort of mutation that makes it look more like a leaf than other insects. This mutation will enable it to hide better from its predators. Those insects which happen to have this camouflage will have a survival advantage that will generally enable them to live longer and have more and better equipped offspring than insects without the beneficial mutation. In a sense, the insect's environment, specifically its predators, will exert a pressure on this species of insects such that those with the protective camouflage will be naturally selected to survive and reproduce.
As more and more time passes, more and more of these changes gradually build up due to various selection pressures, such as predators, climate, or scarcity of resources. This causes the overall population to develop new features that better equip its members for survival in their environment. After this process repeatedly occurs all across the globe, we end up with a wide variety and complexity of life on Earth.
Despite the great promise of Darwin's theory, it didn't offer a precise hereditary mechanism through which parent organisms pass down traits to their offspring. Such a mechanism wasn't provided until Watson and Crick's 1953 discovery of DNA, a molecule whose incredible double helix structure enables it to self-replicate and thereby serve as the foundation of genetics. This discovery shifted the emphasis of evolution from the traits of each organism to its DNA's genetic code, the blueprint which contains all the information on how to make the organism. When combined with genetics, the theory of evolution explains how highly complex and diverse organisms can develop from the information encoded in DNA, which is itself a complex self-replicator. The combination of this self-replicator and different environments allows for selection of those versions of the replicator that are better adapted to surviving and reproducing in each particular environment.
Based upon this understanding of evolution, most biologists view the mechanisms of variation, natural selection, as unintelligent causes that are capable of bringing about extremely well-designed living organisms. Biologist Richard Dawkins calls natural selection a blind watchmaker, insofar as it seems to bring about great design and complexity without intelligence or the ability to see any predetermined goal or purpose.
You know, Aaron, while pretty much everyone accepts the basic mechanism of Darwinian evolution, not everyone agrees that the theory of evolution is adequate to explain all of Earth's various complex life forms. There is a lot of controversy surrounding the ability to truly explain all of the design in biology based upon evolution, a blind watchmaker.
Be that as it may, Ellie, you have to admit that evolution is a valid and very successful scientific theory. To determine whether it's completely successful in explaining all the diversity and complexity of life is a fascinating topic, but it's beyond the scope of what we're doing on Physics to God. But there is a question which emerges that is directly relevant to us. Doesn't the blind watchmaker of biological evolution conclusively show that an unintelligent agent is capable of producing an entity which exhibits remarkable order, complexity, and design? Doesn't this undermine the argument from the fine-tuning of the constants of physics and reveal that it's not truly evidence for an intelligent cause?
Let's see why the basic approach of evolution doesn't work for physics. Firstly, it's important to realize that it only became possible to believe that all life forms gradually evolved after science discovered real evidence in this direction from the fossil record. The discovery of fossils of extinct species showed that the species were not fixed and unchanging, as was believed for thousands of years. The realization that species could change made it legitimate to posit the theory of evolution. On the other hand, when it comes to physics, as far as scientists know, the fundamental constants are constant, hence the name. Scientists observe that the constants are fixed as far back as we can measure. Keep in mind, the constants are the fundamental quantities of the laws of nature. Just as the fundamental law of gravity doesn't evolve over time, as far as we know it, the constants don't either.
In order to make it reasonable to posit something like the theory of evolution for the constants, physicists would have to discover real evidence that showed the constants went through various stages of evolution, as in the fossil record of biology. Even if it were discovered that some constants varied over time, it still wouldn't allow the theory of evolution to apply to the constants. Scientists would have to find real evidence that the constants change under some selection pressure, and there's no evidence for anything close to that. This is because a selection pressure in biology comes from the environment. Like the insect's camouflage enables it to hide from predators in its environment. But there's no environment for the universe itself. The universe is everything that there is and already contains every environment.
To summarize, one reason why the fine-tuning argument in physics is better than the design argument in biology is because there are real fossils in biology, but there are no fossils in physics. Not only is there no evidence for evolution regarding the laws of physics, but additionally, the very idea of a selection pressure coming from the external environment, like the need to escape predators, makes good sense in biology, but doesn't seem to transfer to the universe as a whole.
One last point before we move on. While biology and physics seem totally different in this regard, in the 1990s, physicist Lee Smolin put forth the theory of cosmological natural selection, which attempted to extend the theory of evolution to the laws of physics. However, this theory ran into the logical problem that Smolin calls the meta-law dilemma. How can you explain the first law of physics, which couldn't possibly have evolved from anything prior? We'll discuss this in more depth in our mini-series on the multiverse.
Okay, so let's move on to the next stage of the story, the origin of life problem. While the theory of evolution can nicely explain the evolution of life, the major caveat is that evolution and natural selection can only operate after an initial self-replicator already exists. However, the entire theory of evolution is predicated upon the prior existence of a special type of replicator that is subject to the laws of evolution. Therefore, it's intrinsically impossible to use the theory of evolution to explain the emergence of the original replicator from non-replicating matter. In a sense, the science of biology could only begin after the first replicating molecule somehow emerged. Modern biology can tell us how life evolved once it got started, but it cannot tell us how it began in the first place. This problem goes to the very foundation of biology, to the moment when life emerged from inanimate matter, to the point where chemistry ends and biology begins. Since the theory of evolution can only tell us how life evolved after it got started, we need an entirely different theory to explain how it initially emerged.
This is a really important point that comes up over and over again in various attempts to explain design. The theory of evolution explains the design of complex organisms by pointing to the design of DNA. But this raises a new problem. How can we explain the existence and complex design of DNA itself? Scientists call this the origin of life problem and recognize it as a problem upon which the biological theory of evolution inherently cannot shed any light. Before we see how biologists deal with this problem, it's important to appreciate that the origin of life problem is nothing other than the problem of explaining design. The fact that there is a conceptual demand for a solution that explains the origin of the first replicator is indicative of the general need to find a cause for order and design wherever it may be found. The discovery of DNA doesn't eliminate biological design, it merely pushes it back one step to the design of DNA.
To illustrate this vital point, let's consider the following analogy. If we investigate a vehicle and recognize the arrangements of its many diverse parts, the clear conclusion to be drawn is that it is the work of an intelligent designer, as opposed to unintelligent blind forces. However, based upon modern technology, this is no longer the case. A blind machine is more than capable of following an algorithm to put together all the parts of the vehicle. Would it be fair to say that vehicles are not the work of an intelligent designer, but of a blind, unintelligent machine? Would it be fair to revise our first notion, which maintained that vehicles are always the product of intelligent design? Certainly not. The machine is merely carrying out what it was programmed to do by very intelligent human programmers. In fact, the abilities of the programmers far exceed that of the designer who builds one vehicle. The machine which the programmer has designed can generate many varied and complex vehicles in a much shorter time than it takes the designer to build even one vehicle.
The same is true regarding evolution and the blind watchmaker. Does the theory of evolution on its own undermine the notion that the complexity and variety of life can only be the result of an intelligent designer? Absolutely not. One must still explain the origin of the amazing complex DNA molecule, which allows the variety and complexity of life to naturally unfold. The theory of evolution merely shifts the focus away from the origin of the first chicken to the origin of the first replicator. A further theory is still needed to explain the emergence of DNA.
One possible solution that biologists have suggested to explain the design of DNA is the Multiplanet Solution. You can find this presented in Richard Dawkins' book, The Blind Watchmaker. The Multiplanet Solution provides an explanation for the emergence of the original replicator that evolution needs to get started.
The basic idea is that the Multiplanet Solution attempts to explain the emergence of DNA by pure luck. However, as we explained in an earlier episode, tremendous luck is generally not a good solution. While a certain amount of coincidence is certainly reasonable, to merely invoke fortuitous good luck to answer all problems is an argument from ignorance, a theory of the gaps.
The Multiplanet Solution tries to solve this problem in two ways. First, it increases the number of chances for DNA to emerge by recognizing that there exist many, many planets on which it could have emerged. Dawkins gives a rough estimate of 100 billion such planets. Since there are so many planets in the universe which are theoretically hospitable to life, even something as unlikely as the emergence of DNA on a single planet becomes much more likely when considering the universe as a whole.
Despite the tremendous number of planets, one can make a strong argument that a replicator that is sufficiently complex for evolution to operate upon requires a degree of complexity that makes it amazingly unlikely to occur by chance alone. To deal with this problem, biologists suggest another method for increasing the likelihood of getting DNA by chance alone. They speculate that the first DNA molecule emerged from a previously existing, simpler replicator, and that replicator from an even simpler one, and so on. Of course, it's much more likely to luckily get the simplest replicator on this chain than to get the very complex DNA molecule. Therefore, biologists suggest that perhaps this simple replicator randomly emerged one time on one planet by chance alone. And then this replicator started a long chain which led to increasingly complex replicators all the way to DNA, and then all the way to the diversity of life. The main point of the multiplanet solution is that you can justifiably invoke chance to explain an unlikely event if you can show that it had many chances to occur, where many is measured relative to the unlikelihood of that event.
Let's give an analogy to clarify the two methods that the multiplanet solution uses to increase the odds of getting a replicator by chance alone. Imagine that the odds of winning a particular lottery are 1 in a billion. Despite these low odds, there are two methods to increase your odds of winning. First, if you buy hundreds of millions of tickets, your odds will increase dramatically. If you win in such a case, then you're not really that lucky after all. By the way, don't try this at home. It'll cost you a lot of money. Buying more lottery tickets can be compared to finding more planets in the universe that are potentially suitable for life. Secondly, if you don't need to get 6 lottery numbers correct to win, but only 4 or 5, that would also make it much more likely that you'll win. Lessening the number of correct numbers needed to win can be compared to reducing the complexity of the first replicator that started life.
Now, upon hearing the multiplanet's explanation for the emergence of a simple replicator, you may be asking the following question. Maybe it's likely for life to randomly occur somewhere in the universe, but what are the odds that it will be here on Earth? The answer to this question is basically the same answer we discussed in episode 4 regarding the multiverse. The multiplanet solution notes that there is an easily overlooked relationship between an intelligent observer and the development of life. That is, the development of life is a necessary precondition for the existence of an observer asking the question about why there's life on Earth. In other words, it's only possible to have observers asking this question on those planets where life exists. Therefore, we shouldn't be surprised to find ourselves on a planet with life because there aren't any intelligent beings on planets without life.
The multiplanet solution transforms that which appears designed, the first replicator, into something which is really just the result of blind chance. It explains the illusion of design by making recourse to the many possible attempts that chance had at getting it right. Before moving on, Aaron, I just want to point out that biologists don't actually have any evidence that a simpler replicator ever existed. They're just speculating about its existence.
That's true, Ellie, but our point here is to explain biologists' solution to the origin of life problem and contrast it with fine-tuning in physics. We're not trying to evaluate how reasonable it is in the framework of biology.
Let's now see 2 reasons why the multiplanet solution in biology doesn't naturally work for fine-tuning the constants. First, it's important to realize that this type of solution only works because scientists have actually observed many planets that are potentially hospitable to life. Before scientists had made such observations, it would have been unjustified to simply posit that there were trillions of planets and then invoke luck. That's a luck of the gaps argument, which can be used to explain everything, and therefore in truth explains nothing at all. For example, to take this to the extreme, given an infinite number of planets, you can get entire chickens by chance alone. There isn't even a need for evolution. In contrast, in physics, scientists have never actually observed any other universes. To simply posit an infinite number of universes and then invoke chance is not a legitimate argument. Physicists know this point and therefore try to justify their belief in an infinite number of parallel universes in other ways. We'll discuss their reasoning and whether it's truly justified in our mini-series on the multiverse.
Another major difference between biology and physics is that life, DNA or a simpler replicator, can in theory be derived from chemistry. Biology is not truly fundamental, but is grounded in chemistry, which itself is derived from physics. Therefore, it's plausible to suggest that given enough attempts, a replicator can somehow emerge from lifeless matter. But the laws and constants of nature are assumed by physicists to be fundamental and underived from anything else. As such, there is no natural way to suggest that given enough attempts, the laws and constants somehow emerge from something else. There simply are no attempts to even talk about. Of course, Multiverse tries to suggest the existence of these unobservable attempts, and we'll discuss and evaluate that as well in the mini-series on Multiverse.
Besides all the ways we've mentioned how the argument from physics is superior to that of biology, there's another point which goes beyond contrasting the two arguments. This point illustrates the deep connection between fine-tuning of the laws of physics and design in biology. Even if the multiplanet solution, coupled with the theory of evolution, is successful at explaining the emergence of DNA and the subsequent diversity of life, it is still a mistake to suggest that life can exist merely as a result of blind chance. This erroneous conclusion is a consequence of viewing life in a vacuum and not appreciating its dependence upon the conceptual structures which enable the basic principles of biology to emerge in the first place.
If you take a step back, you can clearly see that even if we grant the fortunate existence of an original replicator through the multiplanet solution, the theory of evolution can only explain life after it also assumes the prior existence of the properly fine-tuned constants in physics. This is because the living organisms of biology are built from the atoms and complex molecules of chemistry, such as carbon, oxygen, water, and amino acids. But the very existence of these entities is based upon the fine-tuned laws of fundamental physics. If the constants of nature weren't set just right, there would be no stable atoms, no complex molecules, no planets, no stars, and consequently, no life.
We now see that an intelligent cause didn't directly create cats, dogs, and chickens. Rather, it designed and fine-tuned the fundamental laws of physics in a way that the atoms, molecules, stars, many planets, and life should naturally emerge. To put it metaphorically, one of the deepest insights of modern physics has been to show that the blind watchmaker itself was fine-tuned and designed by an intelligent cause in just the right way that allows the watchmaker to blindly make watches.
Before we end, let's summarize the three major advantages of the fine-tuning argument in physics over the design argument in biology. First, there are no fossils in physics. Biology has actual empirical evidence that life evolved because of the fossil record, but there's no comparable evidence in physics that the constants change and evolve under some sort of selection pressure. Second, the multiplanet solution only works in biology because scientists have actually observed other planets, but physicists haven't observed other universes. Third, biology is not truly fundamental. Even DNA can in theory be derived from chemistry, but the laws and constants of nature are fundamental and can't be derived from anything else.
In general, all 3 points can be encapsulated by comparing the alternative theories proposed by scientists in their respective fields. In biology, the alternative is evolution, a scientific theory that has a tremendous amount of empirical support behind it. Therefore, the intelligent design argument in biology is an argument within science about how successful and comprehensive evolution is as a scientific theory. On the other hand, in physics, the alternative theory is the multiverse, an unverified theory of an infinite number of unobservable universes. Since there is near scientific consensus about the fine-tuning of the constants, the fine-tuning argument is not an argument about the science. Rather, it's about the proper philosophical conclusion to infer from the science.
And lastly, there is the final point, that the design in biology is ultimately dependent upon fine-tuning in physics, while fundamental physics isn't dependent on anything else, of course other than an intelligent fine-tuner.
You know, Aaron, when we were discussing the origin of life problem, we said that you can't just explain the design of life by saying that it all came from DNA. Since DNA is itself design, it just pushes the question one step back. What designed DNA? But we're saying that an intelligent cause explains the fine-tuning of the constants of nature. Doesn't this beg the question of who fine-tuned the intelligent fine-tuner? Doesn't this show that our whole argument doesn't really solve anything?
That's a great question, Ellie, and it's something we're going to take up in depth in the separate mini-series about God. The short answer is that if someone were to argue for a complex God with parts that needed fine-tuning, that would indeed be begging the question. But we're going to demonstrate that the fine-tuning argument points to the idea of a simple God with no parts, and is therefore intrinsically not subject to fine-tuning. I know that might not make a lot of sense when I say it in just 2 sentences, but we're going to develop the entire line of thought in great depth later. We can't do everything at once. If we try to explain fine-tuning, the multiverse, and God all in the same episode, everything would just become one big mess. We need to have patience. We'll get to everything in its proper time.
That makes sense, Aaron. But I had to raise the question so someone doesn't think we're ignoring major problems with our own theory. In the meantime, we're going to move on with this miniseries. Next time, we'll discuss a new point about the amazing design of the qualitative laws of physics. Stay tuned. I'm Rabbi Dr. Eli Fader.
And I'm Rabbi Aaron Zimmer. And this is Physics to God.